Okay, let's start with some easy stuff. So let's look at number 1, and let's simplify those two things, pulling out some exponent rules. So what would A be? 1 over x squared. You're subtracting, and then the bigger exponent's on the bottom, so it stays on the bottom. What about B? 3x squared. Good. Okay, looking at number 2. These are the most common mistakes that I see students make in this section, in this chapter. And I hate when people make these mistakes, and I have a meme. I don't know if it's on my board or not, but basically every time you do something like this, a puppy dies. It's sad but true. It is. So don't do it. You cannot cancel these x squareds right here because you have this plus sign. You cannot cancel this x and 2x because you have this plus sign. And you cannot cancel the 10 and the 10 because you have this plus sign. So if you have a plus or a minus on the top or the bottom, things cannot cancel. So if plus or minus cannot cancel. You can only cancel when things are multiplied by each other, when they're factored. So when we're simplifying rational expressions, and what does the word rational mean? Like, that's what this whole chapter is about, but what does that actually mean? What is a rational? No. A rational is a fraction. So it means that it has an x on the top and an x on the bottom, or it at least has an x on the bottom. So at least x on denominator. At the very least. So some rules. The first step, I like this section because you can make it very methodical. Like you can do step 1, 2, and 3 and then be done. So the first step is you are going to look for factors that are common to the numerator and the denominator. So first step is you're either going to find GCF and or factor the numerator and denominator. So basically you're going to isolate the top, factor GCF, and then you're going to isolate the bottom, factor GCF. So basically simplifying top, simplifying bottom. Second step is you can cancel the common factors. And simplify what is left. The big thing, though, is you can only cancel factors, not terms. So I'm going to write this in all caps. Can only cancel factors, not terms. So what I mean by that, I'm going to come up to the top and I'm going to show you an example. So let's say that I have x plus 2, like 3x plus 2 over x plus 2. These x plus 2's are factors, so that means that they can cancel. This is okay. But if I had 3 plus x plus 2 over x plus 2, these could not cancel. No canceling. If you cancel, a puppy dies. Because of this plus sign right here. So since they're multiplied here, that's okay. This plus sign makes it not okay. So you might see like, so simplify this rational and include the excluded values, or write down the excluded values. And we'll get more into what an excluded value is when we start graphing, but it's an asymptote. That's basically like where the rational does not touch, or the function doesn't touch. Because anytime, so if I had a number where the denominator was 0, what do we call that? Like 1 over 0, what is that? Undefined. Because basically the graph just kind of blows up. It just shoots off. It doesn't ever touch whenever the denominator is 0. It's undefined. So to find an excluded value, we're just going to set the denominator equal to 0. So after we've simplified everything, then we go and set the denominator equal to 0. So for instance, on A, what would my excluded value be? X equals what? 1. And for B, what would my excluded value be? 0, because 4x equals 0. Divide by 4, you just get x equals 0.
Wait, how are you doing this?
I'm just setting the denominator equal to 0. Okay, so we're going to look at a few examples before we start multiplying and dividing. So for number 3, I want to look at the top, and I want to first pull out a greatest common factor, and then factor if I need to. So for the top, what can I pull out? So what do they have in common? No. I'm just looking at the top right now. Just x. So I'm looking at it, the top and then the bottom. So x on top, then I'm left with what? X plus 4. On the denominator, what can I pull out? What's my greatest common factor? X squared. I'm left with x plus 4. And they can cancel because they are factors. So since everything's multiplied, I can cancel. And I'm left with x over x squared. And can that be simplified further? 1 over x. Perfect. 1 over x, the excluded value would be x equals 0. So I should have put a not equals because they can't equal that. So my bad. That's an excluded value because x cannot equal 0. So x can equal anything, but it can't equal 0. Okay, I want you to try number 4. So I want you to factor the top, factor the bottom, and then cancel those factors. Okay, so you factor the top, the x plus 2, x plus 3. Factor the bottom, x minus 5, x plus 2. The x plus 2's cancel, and you're left over, so you just write whatever you're left over with. So I have x plus 3 on the top, x minus 5 on the bottom. And then set the denominator equal to 0, x cannot equal 5. Okay, try number 5. Okay, so let's go over this one. You factor the top, and then you factor the bottom. What did we call this little guy? Remember him? A difference of squares. Those were the days. Those were the days. X plus 1, x minus 1, keep the x plus 6. Then you get to cancel. Boom. Boom. So that's the fun part. You get to just like slash through your math homework. And then you're left with 1 over x plus 1. I knew you liked that. And x cannot equal negative 1 because you set the denominator equal to 0. Are we okay with that? We just need practice, I promise you. So the first thing, when you're dividing, if you're dividing, so you have a fraction divided by another fraction, what do you do? So if division, how do you go about solving that? What do you do to the second one? So if division, flip the second fraction, then multiply. Okay, second step is you want to factor the top and the bottom, numerator and denominator. And then I put slash GCF, so you may have to take out a greatest common factor too. So look to do both of these things. So then you still have you still have two separate fractions. So combine and write as one fraction, one big fraction. Nope. And then the fourth step is just simplify if needed. Okay, so what I want to do is I've got two separate fractions, so let's look at them in four entities. I'm going to look at each one, I'm going to factor them. So top left, how would I factor that? X minus 4, x plus 1. Bottom left, it's a difference of squares. X plus 4, x minus 4. And then I'm just going to extend this line out, just make that step 2 and 3 easier. Can I do anything to the top right? No, so I'm just going to put it in parentheses as x plus 3. And what do I do to the bottom right? Good. This is the fun part. Slash through the factors. So what can cancel? X minus 4. Boom. What else? X plus 1. Is that it? Yes. So I rewrite it as, I kind of ran out of room, x plus 3 over x plus 4. You could write x plus 4 squared, or you could just put x plus 4 twice. And what would be an excluded value? X cannot equal what? Negative 4. So try number 1. So factor top left, difference of squares, so x plus 3, x minus 3. The bottom, you would do a negative 8, positive 3. Top right, you can't do anything, so you leave it as x minus 8. And bottom right, all you can do is just take out a greatest common factor, which is 2x. And then you're left with x plus 9. Then the 3's cancel, the 8's cancel. And I'm left with x minus 3 on the top, 2x, x minus 9 on the bottom. When you're finding your excluded values, you're looking at the 2x and the x minus 9. So this equals 0, equals 0. Or I guess it doesn't equal 0. So anytime it's just a single term, you're going to say x does not equal 0. Okay, try number 2. Okay, number 2, all you can do is pull out a GCF on top, the 3. Can't do anything on the bottom. So you have x times 3, x minus 9. Whenever I rewrite this, I put the 3 in front, just because it bothers me to have an x then a 3. And the x minus 9's cancel. Okay, looking at dividing, so the first step when I divide is I'm going to flip the second one. So, yes, sir.
I have a question on the one before. Why was 0 as one of the things that you do a negative, or that it's not equal to?
Oh, because so you have 2x and then parentheses x plus 3. Is that it? Or x? X minus 9. So you look at each section, like you look at the 2x and you set that not equal to 0, and then the stuff in parentheses not equal to 0. So when 2x does not equal 0, x does not equal 0. Yeah, so you look at both of them because they're separated by the parentheses. Okay, so dividing, I'm going to flip the second part. And you can do these as all separate steps at first, but I think you're going to do so many of these that it'll get to the point where you factor and flip at the same time. So I'm going to rewrite it as x plus 5 over x plus 1. So it becomes flipped. Now to factor the top left, what would I do? X minus 3, x plus 1. How would I factor the bottom? X plus 2, x minus 2. Then I'm going to write the flipped version, so x plus 5, x plus 1. Didn't need that long. Now I start canceling. Ones cancel. Okay, I guess that's it. So I am left with, it's kind of sad when you don't have very many things cancel. I think there's an example where everything cancels and you just feel like you conquered the world. You're just left with like 1. And x does not equal what? 2 and negative 2. Okay, let's try 3 and 4. Okay, so if we change this to 2x minus 6, then things would cancel. The x minus 3's would cancel, and you're left with x plus 11, x plus 1, and then the 4 and the 2 combine to be 8. And then excluded value would be x does not equal what? 0. Okay, try number 4. So you should get 4 over x squared. X does not equal 0. Are you okay with that one? Good. Okay.